Hi, in this tutorial we have an exercise related to reaction mechanisms. The exercise asks us show the reaction mechanisms using curved arrows for the following reactions. Let's start from the first one. The first one, we have methyl alcohol reacting with hydrogen iodide, and the alcohol is protonated, and we have an iodide anion here. So after describing what happened in the reaction, we can write the reaction mechanism. Okay, let's rewrite the reaction showing with lone pair electrons. So we have methyl alcohol. We know that oxygen has two lone pairs plus hydrogen iodide. In iodine, we have three lone pairs. And what is happening? We have oxygen connected now with two hydrogen, and oxygen is positively charged, and iodine having four lone pair electrons and having a negative formal charge. Okay, now let's add the curved arrow. In the reaction, oxygen should be connected with the hydrogen of hydrogen iodide, and we have to use the curved arrow starting from one of the lone pair electrons of oxygen ending with the connected hydrogen in the product. Okay, then we know that the bond between hydrogen and iodine should be broken, and the bonding electrons between hydrogen and iodine should be on iodine, because in the product we have four lone pairs of electrons, so the fourth lone pair should be coming from the bonding electron. So this is the first reaction mechanism. We added two arrows. Let's look at the second reaction. The second reaction, we have methylamine reacting with hydrogen chloride. We are protonating the amine. We are having protonated methylamine, and we have the chloride anion. We have two products. Okay, after describing what happened, let's rewrite the reaction showing the lone pair electrons. It will help us to be able to write the reaction mechanism. Methylamine, we have methyl, and we have amine part. We have two hydrogen attached to nitrogen with a lone pair, plus hydrogen chloride. The chlorine has three lone pairs. And in the product, nitrogen is now attached to three hydrogen instead of two hydrogen now, and it has a positive formal charge. Plus we have chloride anion, and it should have four lone pairs, and it has a negative formal charge. Now again, let's add the curved arrow to this reaction. We know that nitrogen and hydrogen should be connected in the product. We know that they are connected. So how do we write the reaction mechanism? We have to start a curved arrow from nitrogen's lone pair ending on the hydrogen. Then this means that we are forming a sigma bond between nitrogen and hydrogen using nitrogen's lone pair electrons. Then we know that the bond between hydrogen and chlorine should be broken, and the bonding electrons should be on chlorine. So we are drawing a curved arrow starting from the sigma bond, and it should end on chlorine as the fourth lone pair electrons. Okay, that's it for this reaction. And the last reaction, we have here an alkene. It's ethene reacting with hydrogen fluoride, and hydrogen is attached to one of the carbon, and creating a positive charge on the other carbon. And we have also a fluoride anion as the product. Okay, now like we have here a pi bond between carbon and carbon, so it's broken, and it is used to make bonding with this carbon and this hydrogen. So let's rewrite the reaction again. So we have carbon-carbon pi bond, and let's write hydrogen fluoride. We have to show the lone pairs of the fluorine. It has 3 lone pairs, and in the product we have carbon having now 3 hydrogens attached. The other one has 2 hydrogen and a positive charge, and we have a fluoride anion with a negative charge, meaning that fluorine should have 4 lone pairs of electrons and a negative formal charge. Okay, now the bond between hydrogen and carbon is formed using the pi bond electrons. So then we have to use a curved arrow starting from the pi bond and ending on hydrogen. This means that we are breaking the pi bond and we are forming a sigma bond between carbon and hydrogen. And then we should break the bond between hydrogen and fluorine should have 4 electron pairs as lone pairs. So the bond between hydrogen and fluorine should be broken, and we are showing with a curved arrow starting from the bonding electrons and onto the fluorine atom. So this is the reaction mechanism. Thank you so much for watching the video.